Hello, this is Alana from Team 2, and this is our Exercise 6 presentation. So starting off, we were asked to use SAS Viya to run a simple linear regression on the exam.csv dataset with exam mark as the target and hours of revision as the predictor. We were supposed to verify that we got the same results as in table 6.9 from our textbook. So here you can see our linear regression. Under response, we have exam mark, and under continuous effects, we have the hours of revision. The R-square, as in the previous slide, was 0.59, and here we can see that it is also 0.59. So we matched the textbook's table, and just to confirm, that is our R-square, and that is the value. Next, we were asked to use SAS Viya to run a simple linear regression using the dataset advertising.csv for radio advertising spend on sales. And spend will be our predictor and sales will be our outcome. So what is the regression equation? If you spend $8,000 on radio advertising, what level of sales would you expect to achieve? Is radio a significant predictor? What is the level of significance? And what is the adjusted R-squared value? And how do you interpret this value? Is the model significant? So here's our model with sales and the response and continuous effects having radio. And as you can see, our R-square is up here. It is 0.3156. So the closer that is to 1, the better. It means that our fit is a good predictor of sales. And here we can see our intercept and the radio with the standard error, the t-values, and the PR greater than the absolute value of t. And here is our regression equation. So sales will equal 68.98 times expenditure on radio plus our intercept of 289.97. So plugging in 8,000 radios or $8,000 spent on radios, we can expect sales of $552,129 or $129.97. My apologies. What is the adjusted R-squared value? How do you interpret this value? Is the model significant? So our adjusted R-square value is 0.3128. And so the adjusted R-square value just takes into effect any outliers and just makes this a better model. And so as you can see, it's slightly lower than our original R-square. So there's a slight difference. Using SAS Viya or a statistical package of your choice, run a multiple linear regression with sales as the outcome and TV, radio, and press as predictors to create a baseline model. Now add an interaction effect between TV and radio to the model. What is the regression equation for the new model? Is the interaction effect significant? Compared with your baseline model, how much has the R-square increased by? Do you think the change in R-squared is significant? How might you test it? So here we ran our regression with press, radio, and TV as our continuous effects and response as sales. So in this regression equation, we're including more variables and more factors to our analysis. You can already see right off the bat that the R-square is a bit higher, even closer to 1. And the line actually looks like it's a better fit. Further proving that the R-square equation, or the R-square value, the higher that gets, the better the goodness of fit is of your model. And here we have our t-values, our PR greater than the absolute value of t, standard error, and estimates that will go into our equation on the next slide. And here's that equation. Sales equals 32.65 times the expenditure on press plus 63.57 times the expenditure on radio, plus $4.18 expenditure on TV, minus 188.14. And so here is that report again. And that is all. Thank you.